So question 1 part A, we first want to write all these fractions as improper or proper. So 1 and 4, 7. 7 times 1, that's 7 plus 4, that's 11 over 7 plus 2/3 minus 6 times 1, 6 plus 5, 11 over 6. So we need an LCM for all these numbers, 7, 3, and 6. So the LCM, that's 42. So 7 into 42, that's 6. 6 times 11, that's 66. Plus 3 into 42, that's 14. 14 times 2, that's 28. Minus 6 into 42, that's 7. 7 times 1, 7 times 11, that's 77. So 66 plus 28, take away 77, that is equal to 17. So our solution for 1 part A would be 17 upon 42. So next we're asked to write the value of the cube root of 27 upon 9 square as a fraction in its lowest terms. So we know 9 square in the denominator, 9 square, that's 9 times 9, that's 81. The cube root of 27, we think of which number will multiply by itself 3 times to get 27, and that number is 3, so 3 upon 81. And if we divide numerator and denominator by 3, this simplifies to 1 upon 27. Next, the thickness of one sheet of cardboard is given as 485 times 10 to the minus 2 millimeters. A construction worker uses 75 sheets of the cardboard stacked together to insulate a wall. Show that the exact thickness of the insulation is 363.75 millimeters. So, one of the cardboard is 485 times 10 to the minus 2 millimeters, of course. And we're asked to find the exact thickness of if 75 are stacked together. So if this is for 1, then for 75, we multiply this by 75. We end up with 363.75 times 10 to the minus 2 millimeters. But 10 to the minus 2, that's 100. So this would be 363.75 times 0.01, because that's what 10 to the minus 2 represents, or you could say 1 over 10 square, which is 1 over 100, which is 0.01. So this would become 363.75 millimeters. And now we are asked to write our answer in part 1, correct the two significant figures. So this 363.75, the two significant figures would of course be 360 millimeters. And correct the one decimal place, 363.75 would be 363.8 millimeters to one decimal place. Next, we are asked to write our answer in standard form. Remember, it was 363.75. So in standard form, we need the decimal point to be here. So it will be 3.6375. How many places did we move? 2 places to the left. So that's times 10 to the positive 2. Next problem, Marco is on vacation in the Caribbean. He changes 4,500, so 4,500 Mexican pesos to Eastern Caribbean dollars. He receives 630 Eastern Caribbean dollars. So you have 630 Eastern Caribbean dollars. And we are told that's equivalent to 4,500 Mexican pesos, right? Now we want the conversion, we want the equivalent, or how many Mexican pesos will make 1 Eastern Caribbean dollars. Alright, so we use this mapping we have here. So 630 Eastern Caribbean to 4,500 Mexican. So we want 1 Eastern Caribbean. So to get the 1 Eastern Caribbean, we can divide both sides by 630. So we're left with 630 into itself. That's 1. So 1 Eastern Caribbean. And then 4,500. 4,500 divide by 630. That's equal to 7.14. So 1 Eastern Caribbean dollar is 7.14 Mexican pesos. So now we're on to question 2. Question 2 part A. We're asked to factorize the expression. Notice for 12 and 4, the highest common factor there is 4. And for the variables here, the highest, we have n square, we have n, so it's n. And of course, m is not common. So we need now the terms for the bracket, so I guess we can divide each of these terms by whatever the highest common factor was, which was 4n. So divide each of these terms by 4n. 4 into 12, that's 3. N squared divided by n, that's n. Minus 4 into 4, that's 1. N into n, so we're just left with minus. N into n is also 1, so we're left with just minus m. And notice when you expand the bracket, you get the original expression. So 4n times 3n, that's 12n squared. And 4n times m, that's 4nm. Mn. Next, part B, we're asked to show that x over 1 minus x minus 4x is equal to x into 4x minus 3 upon 1 minus x. So let's take it's a proof, let's take the left hand side. LHS, abbreviating left hand side. So left hand side is x upon 1 minus x minus 4x. And we want to simplify this and show it's equal to x into 4x minus 3 upon 1 minus x. Go now, so of course we want a common denominator. We want both denominators to be 1 minus x. So the idea of equivalent fractions, I multiply the denominator here by 1 minus x, which means I also need to multiply the numerator by the same 1 minus x. Notice now both denominators are 1 minus x. This is x, and here denominator 1 times 1 minus x, of course, is 1 minus x. And the numerator we can expand. So 4x times 1, that's positive 4x. And 4x times minus x, that's minus 4x squared. Now, because both denominators are the same, of course, we can put the numerators together over the one common denominator, 1 minus x. So what we have here is x, and then it's minus all of these terms in the numerator here, so it's minus 4x. Let's think of it like this. So we're applying minus to each term, and then minus minus, so it's positive 4x squared. Now let us group like terms. So here we have 1 minus x. Let me just put the 4x squared at the front here. If I'm grouping, this is 1x. 1x minus 4x, that's minus 3x. And of course, we can factorize the numerator by extracting x as the highest common factor. So if we factor out x in the numerator, we are left with 4x minus 3. Notice this is what the right hand side is equal to. Alright? So therefore, the proof is done. Next, we're asked to solve this equation. Notice we just proved that all of this on the left hand side here is equal to x into 4x minus 3 upon 1 minus x. Alright, so we can rewrite left hand side just like this, and of course that's equal to 0. And of course, if cross multiply, we would have x into 4x minus 3 is equal to 1 minus x times 0, so that's 0. So notice we can equate both brackets to 0. So hence x is equal to 0. Also 4x minus 3 is equal to 0. And we solve this equation, 4x equal to positive 3. Divide both sides by 4. So x equal to 3 quarters. So x equals 0, x equals 3 over 4 would be our solutions. And the reason, remember, what we have here on the left hand side, we just prove it's equal to this. Right? So we can replace all of this with all x into 4x minus 3 upon 1 minus x. Let's move on. Next, we are asked to make v the subject of the formula. So to get rid of the square root, of course, we can square both sides. Square both sides. So we square the left hand side, we end up with p squared. We square the right hand side, we end up with 5 plus vt. So remember, we're asked to make v the subject, meaning we want v by itself on one side of the equation. So we can subtract 5 from both sides. Subtract 5 from both sides. On the left hand side, we end up with p squared minus 5. And on the right hand side, we're left with just vt. And of course, we want to get rid of the t from beside the v, so we can divide one side by t, divide the other side by t. So t into itself, that's 1. So we're left with just v, and that's p squared minus 5 upon t. So that's our solution. V is equal to p squared minus 5 upon t. Next, the distance, let's call distance d, needed to stop a car varies directly as the square of the speed. So the distance varies directly, so k, times the square of the speed. That's s squared. A car is traveling at a speed 70 kilometers per hour. So if s is 70 kilometers per hour, requires a distance of 40. So let's use that to find the value of k. So if d is 40, k times s squared, s is 70, right? So times 70 squared. So 40 equal to k times, now what's 70 squared? 70 times 70, that's 4900, is it? 4900 k. So we divide both sides by 4900. So that into that. So the value of k, so 0 into 0. So 4 into 490. So this is 4 upon 490. I'm sure it can be simplified further, but let me keep that 4 upon 490 for now, which means that, so the line here, which means that d is actually k, which is 4 upon 490 times s squared. Now we are asked, what distance is required to stop a car traveling at 80? So now they give us the speed is traveling at 80, and they ask us for the value of d, distance. So d equal to 4 upon 490 times 80 squared. Alright, let's do the calculation now. So d equal, let's write this out. So 4 divide 490 times 80 times 80, that would be equal to 52.24. So 52.24 kilometers. Actually, it's the distance should be meters, sorry. So 52.24 meters. Note that the distance in the original is given as meters. So of course, so 52.24 meters. Next, question 3, part A. The diagram below shows two pentagons P and Q drawn on a grid made up of squares. And here are the pentagons. So here's pentagon P, and here's pentagon Q over here. And we're asked to select the word from the following list to complete the statement below. Are they opposite to each other? No. Is it a reflection? No. Is it a translation? No, because if it's a translation, remember the shape when the object is translated, the general form of the shape does not change. So it's, I guess it's both shapes are congruent. So in answering this question, pentagon P is congruent to pentagon Q. And the reason for our answer, pentagon P and pentagon Q, they have the same size, and of course the same shape, same size, same shape. So hence they are congruent. Now in part B, we are given a diagram not drawn to scale, VW XYZ. We are told that this side YZ is parallel to XW, and we are also told that YX, where's YX is parallel to VW, and we are given some angles here, 98 and 114. We're angle. So this is 114, this is 98. We're asked to determine the size of angle WXY. That's this angle, WXY. Now we can reason these angles different ways. Now if I should extend this line, let me just extend this line. If I should extend this line, alright, notice angles on a straight line add to give 180 degrees. So this angle, of course, would be 180 minus 14, which would be what? 66. So this angle would be 66 degrees. Which means that if I should extend this line, because these two lines, ZY and XW, these lines are parallel, so the angles of course will be the same. So this is, and this side it will be 66 degrees, and over here it will be 114 degrees. So of course angle WXY would be 66 degrees. Next we are asked to find angle ZVW. Let's go back up to the diagram. ZVW, that's which angle? ZVW, that's this angle. Of course, calculate this angle first. Note if I should extend this line. Alright, notice VW is parallel to YX. So if I extend this line, this angle is 66 degrees. We will alternate angles, and this angle of course will be 114. Now, the sum of all angles, now what we have is a five-sided shape, it's a pentagon. Alright, and we will the sum of angles in the shape for a pentagon is 540 degrees. Alright, and then to get the 540, there's a formula, 2n minus 4 times 90. Alright, this gives us the sum of all the interior angles. Interior angles, of course. Interior. So this is a formula for sum of interior angles. N is the number of sides. Now this shape has how many sides? 5 sides, right? So n would be 5. So 2 times 5, that's 10. 10 minus 4, that's 6, and 6 times 90, 6 times 90, that's 540. Alright, so the sum of the angles, all the interior angles for this shape is 540. Let's add up all the angles. So, we have 98, we have 114, we have 66, we have another 114, and the angle we want to find here, this angle here, angle V, we don't know what it is, that's what we're trying to find, equal to 540. So the sum of all the angles in a 5-sided shape should be equal to 540. Alright, let's add up all these values now. So of course we have V plus, and then we have 98 plus 114 plus 66 plus 114, and the sum here is 392. And of course, to get V, we subtract 392 from both sides. So we know with V equal to 540 minus 392. So angle ZVW, this angle in question, 540 minus 392. That's 148 degrees. So this angle is 148 degrees. So in part C, we have a letter A, and here's letter A, and we have a point here, 66, located at C, 66, we are shown on the grid below. And then what are we asked to do now? We're asked to, on the diagram there, to draw accurately each of the following transformations. 1, the enlargement of the letter A by scale factor 2 about the center 66. And part 2, the translation of the letter A using the vector t equal minus 3, 2. So let's first do part 1, the enlargement, scale factor 2, center 66. So now let's do the enlargement. So if I draw a line, here's the center, 66. If I draw a line from the center of the enlargement, 66, let's do it point by point. So I draw this line. So we're enlarging this point. Alright, so how far? So 2 diagonals away. So the image point will be here, this point here. The new image point would be now here, same distance away, which is here, right? So notice the distance from the point to the center point is the same distance from the point here to the image point. Alright? So let's draw a line here now from the center point to this point here on the A. So how far is it? Notice the distance, 1, 2, 3, 4 down, and 1 across, so the same distance to image point, 1, 2, 3, 4 down, and 1 across, so the same distance. So the distance between this image point to this point here is the same as this distance from this point here to the center. And of course, notice this is one leg of the A. So notice the other leg is 2 units apart. Alright, so 2 and then 2 over here. So it will certainly be here. So that's our enlargement. So let's draw A. And of course, so that's our enlarged A with center 66, scale factor 2. Notice the length of this was a unit, so the length of this will be twice. Whatever the length of this line is, the length of this line would certainly be 2 times. And the length of here, this leg of the A would double this size to get this size, right? And the same with the other side here. Next, we're asked to, let's see what we're asked next to do. We're asked to translate the letter A using the vector minus 3, 2. Minus 3, 2. So minus 3, 2. So minus 3, 2 means, so point by point, minus 3, 2 means we'll go 3 places to the, so minus 3, 2. The vector minus 3, 2 means we go 3 places to the, well, not 3 over 2, 3, 2, right? So this means we go 3 places. Each point going to move 3 places to the left and 2 places up. So this point, three places to the left. So notice the first X movement, then Y movement. So this point, 1, 2, 3 places to the left and 2 places up. This point, 1, 2, 3 places to the left and 2 places up. And this point, 1, 2, 3 places to the left and 2 places up. So this is the translation. Notice when an object is translated, the size does not change and the shape does not change. So that's the translation. So this diagram, so this is answering part 2 of the question, and this is answering part 1 of the question. Let me just remind you what the questions were. Alright, so part 1 was the enlargement, which is what we have here, and part 2 was the translation. Notice when the object was enlarged, the size increased. Each length of each side was doubled, and when the object was translated, the size did not change, the shape did not change. Each point moved 3 places to the left, which is what the negative 3 indicates, and 2 places up, which is what the positive 2 indicates. Question 4. The function f is defined as f of x is equal to 3 minus 2x. The diagram below shows a mapping of the function here, determine the value of a. So notice these are the x values, these are the corresponding y values or f of x values. So we want the value of a. Notice the value of a occurs when the value of x is minus 1. So to find the value of a, so a is actually f of minus 1. Alright, and it's a function, we replace x with minus 1, so it's 3 minus 2x, but we're replacing the x with minus 1, so it's minus 2 times minus 1. So it becomes 3 minus 2 times minus 1, that's positive 2. So the value of a is 5. Next, we're asked to find the inverse of the function. Remember that f of x was 3 minus 2x, right? So for the inverse, we'll let y equals interchange x and y. So x equal to 3 minus 2y. And after we interchange x and y, we solve for y, of course. So let me just group the y over here. So negative 2y is positive 2y over here. And we have positive 3. And so the negative x over here, right? Of course, you're solving for y, so we divide both sides by 2. Right? So y is 3 minus x upon 2, which means therefore, as f inverse x is 3 minus x upon 2. So next we're asked to find the composite f squared x. So f squared, that's ff, times f of x, which means you sub the function into itself. So it's f, and remember the function was what, 3 minus 2x? So we're going to substitute 3 minus 2x into itself, meaning in the function here, 3 minus 2x, wherever we see a x, we're going to replace the x with what we have in the bracket, 3 minus 2x. So f of x is 3 minus 2x, but the x will be replaced with what we have in the bracket, 3 minus 2x. And of course, we can simplify this. We can simplify this by expanding. So we have 3 and minus 2 times 3, that's minus 6. And minus 2 times minus 2, that's positive 4x. Alright, we group like terms. I put the 4x here, and then 3 minus 6, that's minus 3. Which means that f squared x is 4x minus 3. Next, we're asked to find the value of f inverse minus 2. Now, let's recall what f of x was. F of x was equal to 3 minus 2x, right? And f inverse x was 3 minus x upon 2. Was that what it was, though? F inverse x. Yes, f inverse x was 3 minus x upon 2. And f of x was 3 minus 2x. Now, f inverse, let me also sort the sides first. F inverse of negative 2. F inverse of negative 2 would mean that we sub negative 2 in the inverse function. Now, the inverse function, 3 minus x upon 2. So 3 minus x upon 2. We're going to replace the x with what we have in the bracket here, minus 2. So 3 minus, and then x is minus 2 upon 2. So that's 3 plus 2. The double negative give us a plus. So that's 3 plus 2. So that's 5 upon 2. So what I have circled here in blue, that's 5 upon 2. Which means that therefore, f of f inverse minus 2 is equal to f of 5 over 2. Or 2.5 if you prefer. Alright, so all of this, remember we just calculated this to be 5 over 2. So it means we can replace it, of course, with 5 over 2. So now we are finding f of 5 over 2. F of 5 over 2 means we replace x with 5 over 2 in the function, in the original function here, f of x. So what we have here is 3 minus 2 times x, but of course, we're replacing the x with what we have in the bracket there, 5 upon 2. So this becomes 3 minus 2 times 5 upon 2, that's minus 5. So our solution is negative 2. That's our final solution. Using a ruler, draw the lines x equal to a half, y equal to x, and x plus y equal 5 on the grid below. So let us draw these graphs one by one. I won't be using a ruler, but let's draw this graph one by one. X equal to a half, y equal to x, x plus y equal to 5. Let's draw them one at a time. So x equal to a half, x equal to a half. So we look for half, and the x, so here's the x-axis, we look for half. Now this is 0, this is 1. So of course half would be midway between 0 and 1. So if I use a ruler, of course you will be using a ruler in your exam. Alright, and of course use your ruler and your pencil, and of course, so you wouldn't be doing like what I'm doing here, because I do not have a ruler. But of course, so draw a line looking like that. Alright, straight up. Alright, x equal to a half. Then we're going to do y equal x next. So this is a line. This is a line x equal to a half, right? This is a line. Let me just label the line here. This is a line x equal to a half. Now let's draw the line y equal x. Now the line y equal x. What's special about this line is that for all the points on this line, the x coordinate and the y coordinate, they both have the same value. Alright? So the line y equal x, x passes through 0, 0. It passes through 1, 1. It passes through 2, 2. It passes through 3, 3, 4, 4, 5, 5, and so on. Alright? That is why the line is called y equal x. Because the x coordinate and the y coordinate, they are the same value. Alright, so 5, 5. So of course, in drawing this line, of course, using a ruler, Of course, I'm trying to draw it as straight as I can. As straight as I can. Alright, I know it doesn't seem straight, but of course, yours would go a million times better than mine, since I do not have a ruler. Alright, so this is a line y equal to x. And again, right, line y equal to x. The other line we're asked to draw was x plus y is equal to 5. The line x plus y is equal to 5. Remember this line x plus y is equal to 5. So this line cuts the x-axis at 5. And how do we know that? It cuts the x-axis when y is 0. Notice when y is 0, x equal to 5. So it cut the x-axis at 5. And it cuts the y-axis also at 5. And how do I know it cuts the y-axis at 5? Notice it cuts the y-axis when x is equal to 0. When x is equal to 0, y is equal to 5. So when it cuts the y-axis at 5, so we can use our ruler and our pencil to join where it cuts the x-axis and the y-axis. So try my very best here. Let me see, I know it pass through the point 2, 3. Pass through the point 3. So let me just draw this line. Alright, and this is our line x plus y equal to 5. Next, on the grid we are asked to label as R the region where x is greater than or equal to a half. That's to the right of this line of x equal to half. Y is greater than or equal to x. That's above the line y equal to x. And x plus y is less than or equal to 5. That's below the line x plus y is equal to 5. So this region we're speaking of. Alright? The region here enclosed. That is enclosed by all three of the lines that we just draw. So now we're at question 5. 60 students took an algebra test which comprised of 15 multiple choice questions. The number of correct answers that each student obtained is recorded in the table below. So we have correct answers, 6 students get 8 correct, 14 get 9 correct, 2 get 10 correct, and so on. Alright? So the number of students who had exactly 13 correct answers. So 13 correct answers, how many students? 11. Alright, look, 13, so 11 students. Next, the modal number of correct answers. So these are the correct answers. So most students got 14 students got 9 correct. So the modal number of correct answers would be 9, since most students got 9 correct answers. The median number of correct answers. Let's see how many students were there. Let's add up the number of students. 6 plus 14, that's 20. Plus 2, 22. Plus 6, 28. Plus 2, 30. Plus 11, 41. Plus 9, 50. Plus 10, 60. So the median number is 60. So divide 60 by 2. Is 30. So the median would be between the 30th and the 31st. Now let's remind ourselves where the 30th is. So 6 and 14, that's 20. 22, 28, and 2, 30. So the 30th is actually 12 correct answers. And the 31st, which would be 13 correct answers. So that so the two middle numbers will be 12 and 13. Divide both sides by 2, so it will be 12.5. So the median number of correct answers of course, would be 12.5. And how we know that? The 30th correct answer is 12, and the 31st one is 13. So again, remember 60 students. So we have 60 numbers, right? And of course 12 and 30. So we have two numbers in the middle. We average them, we get 12.5. Next, the probability that a student chosen at random had at least 12 correct answers. At least 12. What does at least 12 mean? At least 12 means 12 or more, right? At least 12 means 12 or more. Let's just go back to the table. At least 12 correct answers. So 12 or more. So it will be from here down, right? From here down. So it will be 2 plus 11, that's 13. 13 and 9, that's 22. And 10, that's 32. So the probability would be 32 over the total, which is 60. And of course, this can be reduced to 8 upon 15, right? So the solution here would be 8 upon 15. Next we move to part B. A group of students wrote a physics exam. Each of the students achieved a grade 1, 2, 3, or 4. The pie chart below shows the result. And we ask that we are told that 39 students, got grade 3. So 39 students achieved a grade 3. As we can see in the pie chart below there. Determine the total number of students who wrote the exam. Total number of students who wrote the exam. Now to find the number of students, now you will notice that 117 degrees, let me put it up here, 117 degrees represent 39 students. Which means that we can divide both sides by 117. So 117 divided by 1, so 1 degree is actually 39 upon 117 students. Now of course, the total number of students, notice in a circle, the amount of degrees will be what? 360 degrees. So to get the total number of students, that will be represented by 360 degrees, of course. So we can multiply, so 360, so multiply by 360. So 360 degrees. So 360 times 1, so 360 degrees. So I multiply both sides by 360. Alright, I get 360 times 39 upon 117. Alright, so 360 degrees. Because of course 360 degrees, the number of students in the pie chart, the total number of students in the pie chart would be represented by 360 degrees. Since this sum of the angles in the circle is 360 degrees, right? So 39 divided by 117 times 360 is equal to 120. Alright? So the total number of students who wrote the exam will be 120 students. The ratio of the number of students who achieved grade 1, 2, or 4 is 2 to 4 to 3. And that's for grade 1, grade 2, grade 4. A student passes the exam if he or she achieve a grade 1, 2, or 3. How many students pass the exam? Now remember, we already know the amount of students who got a grade 3. So we need to know the amount of students now who receive grade 2. Now the ratio for grade 1 and 2, sorry. Now the ratio for grade 1 and 2, 2 and 4 here, would be what? 6. So 2 and 4, the total ratio is what? 2 plus 4, that's 6, 6 and 3, 9. But for grade 1 and grade 2, that's 6. So grade 1 and 2, so amount of students who achieve grade 1 or grade 2 would be 6 upon 9 times the total number of students, which would be 120. Now actually, it wouldn't be 6 upon 9 upon 120. If you remember, just check back quickly. If you remember, 39 students got grade 3. The ratio is just between, the ratio we're given is just between grade 1, 2, and 4. Because grade 3, we already know that 39 students got grade 3. So we'd have to subtract 39 from the 120. So if we remove 39 students from the total of 120, grade 1, 2, or 4. For grade 1, 2, or 4, the total amount of students here will be 120 minus 39, which is 81. So we're talking about 81 students remaining with grade 1, 2, or 4. Because remember, 39 students got grade 3. Alright, so we're left with 81 students. So in this total, it will be 81 students. Alright? So 6 over 9 times 81, which would be equal to, well, 9 into 81, that's 9. 6 times 9, that's 54. Alright? So 54 students got grade 1 or 2. Alright? So the number of students who pass, number of students who passed would be those who get grade 1, 2, or 3. Now for grade 1 or 2, that's 54. Plus remember that 39 students got grade 3. So it's 54 plus 39. What's 54 plus 39? 5 and 3, that's 80. 84. 89 and 4. That's 93. So 93 students passed the exam. Determine the value of the angle for the sector representing grade 1 in the pie chart. Now, how many students got grade 1 again? Look, let's look at the ratio. Grade 1, here's the ratio. Grade 1, 2 out of the total ratio is about 2 plus 4 plus 3, that's 9. So 2 out of 9 times 81. So the number of students who got grade 1. The number of students who got grade 1. So number of students who got grade 1 would be 2 over 9 times 81. So 9 into 81, that's 9, 9, 2 is 18. So 18 students got grade 1. So the angle of sector representing grade 1 would be the angle for grade, the amount of students in grade 1 is 18, and the total number of students was what? 120. So 18 out of 120. 18 students out of 120 students times the 360 degrees. Because remember, the total angle in the circle is 360. So it would be 120 into 360, that's what, 3. So it's 3 times 18. So that's 54 degrees. So the angle representing grade 1 would be 54 degrees.